titration requires two standard reagents and one unknown ... One of the standard reagents is added in excess to the unknown, and the mixture is titrated against the second standard reagent. Procedure for calculating the unknown ... Number 1. Calculate the number of moles NaOH used to titrate the unreacted excess reagent. From the moles of sodium hydroxide, NaOH, determine the unreacted HCl by their mole ratio from balanced chemical equation of HCl and sodium hydroxide. 3. Subtract unreacted number of moles of HCl from the total number of moles of the excess reagent, HCl. 4. Determine the number of moles of the unknown from the number of moles of the excess reagent HCl that reacted with the unknown by their mole ratio of combination from the chemical equation. We can proceed to the laboratory for the experiment. 1. Measure your sample. 2. Transfer the sample dot to the conical flask. 3. Measure 50 milliliters of distilled water and add to the conical flask. Swirl to form a suspension. Measure 25 milliliters of the 0.1 molar HCl and add to the suspension. Swirl for proper mixing. Five. Warm the mixture to near boiling. Note the difference. Allow the mixture to cool. 6. Add 2 drops of indicator to the conical flask. 7. Transfer the 0.1 molar sodium hydroxide solution to the burette. Adjust solution level to 0.00 mark. 8. Titrate the clear mixture to pale pink. Record the initial burette dot reading before titrate. Please do like, subscribe, and get notified. Share. Calculations.
Calculations. Amount of moles N is equals to molar concentration times volume in liters. Example, if the average volume titer of 0.1 molar sodium hydroxide is equals to 5.00 ml, the number of moles N is equals to molar concentration times volume in liters. Number 1. Calculate the number of moles of sodium hydroxide. Now, concentration of sodium hydroxide is 0.1 molar. Volume in liter of sodium hydroxide will now, by conversion, will be equals to 0.005 liters. Hence, the number of moles of sodium hydroxide is equals to 0.10 molar times 0.00 ml, which will result to 0.0005 moles. 2. Calculate the number of moles of HCl unreacted from balanced chemical equation. The mole ratio of reaction between HCl and sodium hydroxide is 1:1. Then 1 mole of HCl reacts with 1 mole of sodium hydroxide. 0.005 moles of sodium hydroxide will definitely react with 0.0005 moles of HCl. Hence, the moles of HCl unreacted is equals to 0.0005 moles. 3. Calculate the total number of moles of excess reagent 0.10 molar HCl. Molar concentration of HCl is equal to 0.10 molar. Volume of excess reagent HCl is equals to 25.00 ml, which is equal to 0.025 liters. Then the number of moles will be equals to 0.10 molar times 0.025 liters, which will now be equals to 0.0025 moles. The reacted moles of excess reagent HCl will be equals to total number of excess reagent HCl minus number of moles of HCl unreacted. The reacted moles of excess reagent HCl is equals to 0.0025 moles minus 0.0005 moles, which is equals to 0.002 moles. 4. The number of moles of calcium carbonate limestone in the sample. Before this can be done, the mole ratio of the reaction should be known. The ratio of reaction between HCl and calcium carbonate is 2:1. This is from the balanced chemical equation. 2 moles of HCl react with 1 mole of calcium carbonate from the balanced chemical equation. Hence, 0.002 moles of HCl react with 0.002 divided by 2 moles of calcium carbonate, which the answer will be equals to 0.001 moles. Hence, number of moles of calcium carbonate in the sample are 0.001 moles. Now, concentration of calcium carbonate can be calculated moles over volume in liters. From our calculation, 0.01 moles of calcium carbonate will now be divided by 0.050 liters, which is the volume of water used to prepare the calcium carbonate suspension. Now, when you divide 0.001 moles by 0.050 liters, it will be equal to 0.02 molar. This is the concentration of calcium carbonate in the suspension.
Thanks for watching.